Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Eran Shir, co-founder and CEO Nexar. On today's episode, he'll discuss real-time mapping and how AI and edge technology can enable safer AV driving. We hope you enjoy this episode. Eran, welcome to the podcast.
Happy to be here.
I'm excited to have you here because dash cams will play an important role in fleet safety. It's been documented with data. It's been documented by insurance companies. So point blank, it will play an important role. But I'd love to know, in your opinion, why are dash cams important and what problems are they solving for drivers? Yes, there's the simple problems if you're in a crash or an incident, it can help you get out of that. But overall, what are the problems they solve for drivers?
Well, let me tell you a personal story from last week. Unfortunately, I was abroad traveling with my wife, and all of a sudden I get a text message from my Nexar camera, saying my car was involved in a collision. Right, so it was my daughter driving with my car, middle of the day. I'm abroad. I get a text message. I get the location of the collision. I get a link to the live stream. I tap it. I start getting a live stream from my camera of the situation as it is. I can start. I'm starting to talk to my daughter and help her manage the situation. She's a 20-year-old. It's her first collision. She's a relatively safe driver, and I'm helping her with that. At the same time, our insurance agents get the same data, right? Like it gets the video of the collision and all the analysis. Within a minute, he was on the phone with her, helping her with towing and with all the red tape, what documents to collect, how to capture the imagery of the other vehicle, etc. It created a lot of peace of mind, right? Like think of in a different world where I don't have my Nexar camera. I'm driving, like I'm getting a call from my daughter. She's, crying and stuff. Like she's been in a collision. I don't know what's what. So first and foremost, I think high-end cameras like Nexar camera provide you with peace of mind. Peace of mind when you drive, when your loved one drive, when your employees, if you're a fleet drive, or even when the car parks, because, we have also a sentry mode, like a parking mode. When the car basically is parked, the camera detects break-ins and collisions and sends me a notification and live stream and all this kind of stuff. So technology today allows for basically creating a bubble of protection and safety and peace of mind. It is imperative from an evidence perspective. It's great from an insurance perspective. It reduces the operational cost, it reduces the headaches, and it reduces the cost for you as a driver or a fleet manager. And so these are just a few of the good things that are involved with installing a camera, buying a camera, especially a connected camera, right? Like the high-end connected cameras. At the end of the day, Ring, SimpliSafe, all of these kind of camera devices that protect your house. The car is just another room in your house that you want to protect from, but it's a really complicated room with many more hazards going its way than just, burglary. So I think it's really essential today, and you don't want to be the last fool standing, not having camera when everyone else have their point of view kind of represented.
What you described, I'll use the term safety blanket. Here you are, you're a father, you're traveling abroad, you're getting a real-time notification, you're able to share it with the insurance to calm down a stressful situation that your daughter's going through because the way that you developed and designed the app and developed the technology. Was the app always part of the strategy of Nexar? Was it always part of integrating that in a situation that you described?
Yeah, actually the app was before the camera.
Oh.
Yeah, because when we started Nexar, connected cameras were not available yet. No one had connected cameras. So we said, okay, we know how to produce a connected camera. We'll just use a phone, right? And we build an app that was sort of like a virtual dash cam, and we played with that for a couple of years. While we were working on convincing Shenzhen, some people that actually build stuff to build us a camera that will meet our standards, meet our requirements, and so it was always a combination for us, especially on the consumer side of camera and app. And now, already 2023, we are able to build and sell standalone cameras that are connected with their own cellular modem, with their own AI chip, all this kind of stuff. We have the Nexa One lineup of cameras that are very capable. They're like an iPhone 12 or iPhone 11 Pro from perspective of AI processing and edge processing. So now we can have it as a standalone, connected also to a web dashboard as well as the app. But for us, the app was important to create a holistic, cohesive, kind of modern experience that connects the camera, the user, and the cloud to give you a full experience.
So today, there's hundreds of thousands of your dash cams in use around the world. You're gathering real world data. You're gathering data from incidents, unfortunately, the one you described, which allowed you to create a product called CityStream Live that's enabling real-time mapping.
Yeah.
That's really, really interesting. Could you talk about this product and why it's enabling you to create real-time mapping, please?
Yeah, of course. So basically, like I mentioned, each of our cameras is basically an AI device that on the lookout, it gets the video stream, the raw video stream, and the sensor data, GPS, accelerometer, all this data every second, every actually fraction of a second, right? Like 50 times a second. And it analyzes it, right? It runs edge AI models on those images, on that stream of frames, and detects things. It detects every sign in America, every construction element, construction zone element, every pothole, every parking space. We detect many types of stuff, something I think like 70, 80 different classes of objects on the road, and we capture images. So if you probably know Google Street View, right?
Yes.
And if you go to Google Street View for your neighborhood, for the street nearby, you'll see images there from a year ago, 6 months ago, right? That's typically or 2 years ago, in some cases. When you go to the same product at Nexa, our virtual camera, that is part of our real-time mapping platform, you'll get images of your street from an hour ago or a day ago, right? That's the scale that we're talking about. We see all of America every day. And that's a game changer because it allows you to understand change. It allows you to understand, well, that stop sign has been transformed by a traffic light, or there's construction now on the 101. So maybe I should go through the 280, or where is the nearest parking spot to my destination? Or my favorite is, how long is the line to Katz Deli in New York, right?
That's a very important one.
That's an important one for me because I'm a foodie, right? So I can get into the virtual camera and literally minute by minute, every 3 minutes or so, see the updated line for Katz Deli. So the use cases are just immense. You can do this for rerouting around black ice. You don't want to go through that road because right now there's black ice on it or there's snow. And I can just go on and on. So this is a revolution in what we expect from maps, what use cases it unlocks. And an important element here is that it totally changes the economics of mapping and dealing with the physical world. Because if you're a Google or an Apple, you're spending like $1 billion a year in updating the maps, right? And it only updates it once a year. Now we're talking about something that is 1,000 times cheaper, that you can update every hour or every day. So imagine all the new use cases that we can unlock, that we can open up, both for operations, both for cities and states, for OEMs, for AV companies, and the list just goes on and on.
I have to say about cats, don't forget to tip when you're at the deli line, because then you get the taste of pastrami before you get there. So if anybody's going, that's a tip. Always tip when they have the tip jar,
Always,
because you
always.
get a taste.
Yes, yes, yes. By the way, I was there last summer where I took my daughter, the one that crashed my car last week. I took her to try it out and see if she can finish up a sandwich. That was my dare for her.
It's a Herculean task.
It
It's a
is.
big sandwich.
It is. It's a part of adulting.
And it's fantastic. I mean, after all, Harry met Sally there, so there you go.
There you go.
When you're developing this technology that you've built, and hopefully you're having a great pastrami sandwich on rye when you develop it, what role does Edge AI play in allowing you to get this real time mapping? So you're getting the cat's deli data in real time.
It's an indispensable role. Actually, this is the foundation insight that made us start Nexel to begin with, right? Like, because me and my co-founder Bruno, we built a machine learning technology, 10 years, 15 years ago at Yahoo. Yahoo bought my previous company, and through that I met Bruno, who was Yahoo's chief architect. And at Yahoo, we built machine learning and AI systems in the cloud, in data centers, right? And then our insight back in 2015 was AI is coming to the edge, and that's going to change the game. And if AI is coming to the edge, you can do intelligence in real time, okay? And mobility was the most important human use case, right? Like when you think on the human condition, where does real time play a role, right? So if I say something wrong to my wife and I don't, fix it quickly, that's a real time use case. But barring that, driving is the place where seconds matter the most and where you want to inject as much intelligence. So we were like, okay, if we could get Edge AI to understand your environment and the same way crowdsource the environment of everyone ahead of you, we could actually prevent collisions, right? Because what happens in a collision scenario? Why do collisions exist? The one fundamental thing is they happen because of lack of time, right? Like if I had 5 or 10 seconds more, 20 seconds more, I get a heads up, there won't be any collisions, right? But the problem is that, 2 seconds ahead of me, there's a truck that blocks my point of view, right? Like I don't see anything beyond the next 2 seconds. So that's my horizon. But if that truck has a Nexar camera and that Nexar camera detects things or the car ahead of it, then no more chain collisions. If there's someone coming from the side and into an intersection running a red light and someone captures that and we detect it, through networking, we can update that within split second, within 5 milliseconds. And you get all of these alerts that could really protect us. So our vision is to really blanket cover the roads with enough eyes so that we can give you that time. We can increase your time from 2 seconds to 20 seconds and eliminate collisions. And that was why it played a big role. The other element where it played a big role is with economics. Because at the end of the day, running AI is expensive, right? Like if you need to upload billions and billions of images, billions of hours of video, store that and process it, that's a lot of power, that's a lot of money, right? Our approach was forget about that. We will push AI to the edge, which is basically zero cost because every camera does a bit and it doesn't cost you extra, right? And all of a sudden, I can give you a nationwide map that even Google cannot afford because it doesn't cost anything because we centralize the problem. So Edge AI is critical for us, both from a use case perspective as well as from a unit economics perspective.
The alert is really interesting. Then, do the individuals in your network, are they getting a real time alert? Collision ahead, black ice ahead. Are they getting real time alerts pushed to their phones, or how is that alert system work in real time?
Yeah, so we actually have a standard that we opened up. We open sourced a standard called Nexagons that has been approved as a standard by the Internet Standards Body. It's called the IETF, and it's part of a consortium called Automotive Edge Compute Consortium. And what it does is it basically creates a virtual IP server for every tile of road on the planet. Right? We basically break the planet into hexagons that are like different sizes, and each of them gets a virtual IP address that you can subscribe to, like you subscribe to someone on Twitter, right? And then you get into a neighborhood, you can say, okay, I want to be, and you, I mean your car, can say, I want to subscribe to all of the hexagons in the 200 yards radius. And we will curate a feed of everything that's new, everything that's happening, everything that's notable in that area. So you would know about construction that is 300 yards ahead that blocks the right lane and continues for 50 yards, right? Or you would know about, okay, there's a stop sign here, or there's a truck there. All this kind of stuff are actually available through our system. We don't yet commercialize alerts ourselves. We give it more to third parties, especially OEMs, to play with. But that's something that I expect us to also commercialize to the broader network in the next couple of years.
So is it very similar to Waze where they say traffic ahead, speed trap ahead? Is that a very similar analogy for listeners sitting here? Okay, this is interesting. Is that very similar from an analogy standpoint?
Well, you can think of it as the marriage between Waze and Tesla, right? So, like when you drive a Tesla, it detects all of the things, you see them, like the cone and things like that. Waze doesn't detect anything, but it crowdsources them with humans as the mechanical Turks adding the data, right? So what we do is basically bring these two together. We say, okay, we don't need human because we have the eyes on the road and edge AI to detect all of the things. So actually you can expand beyond the 3 use cases that Waze gives you. You can expand to limitless number of use cases, and you can use the real-time networking in order to bring it all together and share it with the network.
It's wonderful. You're gathering, you have over 400 million miles of road data being gathered each month on public roads. I want to repeat that. Over 400 million miles of road data being gathered each month on public roads. That's a lot of data. How are you using that data? Are you using that to enhance your maps, enhance your AI algorithms? What are you using all that data to do?
Yeah, all of the above. We use it first and foremost for our real-time mapping suite. For all of those products that I mentioned, all of the, okay, what's new around the corner, which signs are new, where do I need to patch a pothole, etc., etc. And then we use it. We use it also to train our models. So if I want to introduce a new use case, let's say for next Christmas, I want to detect people on the road walking on the sidewalk wearing Santa Claus clothes. Okay, so that's an important use case, almost as important as Cat's Deli, and. But it's simple for us because we have these trillions of images that we can kind of use for training, right? So you can find those use cases for whatever use case you're interested in. Then the third thing that we use the data, especially all of those corner cases, collisions, hard brakes, etc. Of course, anonymized. All the data, I must say, is anonymized. It's important. We actually use it to train autonomous vehicles. And that's something that is really exciting, really cool. Because, Tesla's claim to fame is that they collect data from all over and use that to train their autopilot. And their claim is that, they have more footprint than the regular AV companies. But we have more footprint, right? We collect more of those events. And so we help AV companies to train their brain and to look into new markets, new cities to expand to. For example, I'll give you an example of a product that we built. We call it Nexar Behavioral Map. And what is it? It is a map that tells you for every road in America what kind of driver behavior you could expect with what probability. And actually, not just driver, also pedestrians, etc. So, what are the chances that people would change lanes in this road? We have the concept of a virtual stop sign. What is a virtual stop sign? Is when you have a place on the road where many pedestrians pass, even though it's not regulated. There's no, zebra crossing. It's not allowed there, maybe even. But that's reality. And you want to know about, if you're an autonomous vehicle, you really want to know about these kind of peculiarities. And they are very geospecific.
Okay, so I've been doing a lot of research, economic modeling. So you stepped into it, and I'm going for it. You mentioned training the AVs with data. I'm doing a lot of economic research around Tesla's Dojo computer.
Yeah.
What are your thoughts on Dojo? So Tesla's gathering real world data, very similar to your gathering the real world data.
Yeah.
Tesla has an AI strategy. You have an AI strategy. What are your thoughts on vision and then using AI to help train a vehicle and just look at the power what Dojo has?
I'm a big believer in camera as the ultimate Uber sensor. We have, for example, we recently shipped our first HD map that is vision only. What does that mean? You know the concept of point cloud, right? That you do with LiDAR and stuff. We do an HD point cloud that is sub 30 centimeter accurate, precise, with a video stream, just capturing a video from a road. And that's a game changer because the unit economics of HD, typically with all of the sensing and the LiDAR and the crunching of it, is in the hundreds of dollars per mile. And we get it down, orders of magnitude cheaper because we can use that. So I think for data gathering, data collection, data modeling, you don't need anything other than a good GNSS, GPS, and a camera. I would say that for like real-time safety, I think the jury is still out if today, in the state of AI today, you can handle any situation just with cameras. I think that's probably a bit problematic today. I think down the line, I am confident that you'll be able to do that. And the reason why I'm confident is because, I have two cameras when I drive and they serve me pretty well. I think beyond that, something though that's worth mentioning from a philosophical standpoint, this market of vehicles is super fragmented. The largest OEM in the world has like 8%, 9% market share, right? And it's super slow, right? Like the turnover is like 10 years, 15 years, whatnot. What does that mean? It means that no one on its own will be able to fully solve this problem. It's going to take a village. And so you want to create an ecosystem. You want to create sort of like an alliance, a consortium, an open standard for different OEMs to share and collaborate and monetize their data. And I think that's where Tesla is a bit wrong, because Tesla is like, we're going to just do it for, just keep it all in the house. We're not going to collaborate with others. And I think that strategy is vulnerable to a bunch of the OEMs colluding or collaborating under a network like ours to really get to scale, to numbers that matter, right? Like I mentioned for you, for example, before, the use case of available parking spots. This is something that we can already deliver in select cities where we have enough density. And I can tell you, okay, these are all the free parking spots in the last 5 minutes in Manhattan. And I can give you an SLA on that. But I cannot do it in every city in the US because we don't have enough density. And guess what? Toyota doesn't have enough density for that. Definitely Tesla doesn't have enough density for that. So if you want to go to this really value added services, you will have to collaborate, you have to do a marketplace, you have to monetize it, and unlock those use cases.
Collaboration is key to enable the future of autonomy. You mentioned camera is the ultimate sensor. Is that because the economics of cameras are highly scalable and it could fit into the traditional supply chain without having to dramatically raise the price of a vehicle?
That's an important element. It's not the only important element. I think the other important element is that cameras are running in the bands, in the spectrum side, where you can map almost any use case to a repeating vision pattern, right? So, when I use radar, right, I don't know whether a sign that I capture is a stop sign or it's a speed limit sign, right? Same thing with LiDAR. So it's basically blind sensing of depth. But cameras together with AI today can do depth, they can do detection, they can unlock tracking, they can unlock a profiling of different agents on the road, they can do anticipation. There are many, many things that you can do with a simple monocular camera that costs, honestly, the camera itself, the sensor costs like $5, right? And it's mind-boggling, right? So the units, you need to build it, you need to put the compute, you need to put all the memory and storage and all of that stuff. But at the end of the day, this is a small sensor that you can embed everywhere. You can make many of them. You can put 8 cameras on a vehicle to do 360, and you can compress the data extremely well. Right? Like I can either compress it semantically and say, okay, I have this bounding box. This bounding box is a sign. I don't need I'm cropping everything else, right? Or I can say, okay, I have here in 15 images. I compress them through MPEG and that's like 1/10 of the size. So we have a lot of know-how of how to deal with video, how to deal with imagery. We have a whole industry around it. Now we have a lot of AI that was trained on it. It's really the Uber sensor.
How important is depth sensing as it relates to the AI in the cameras? Is that, would you say, a critical technology, a critical breakthrough?
Yeah, it is very, very important. It's important first and foremost for localization, right? So one thing we should all remember is that GPS is crap, right? Especially in urban canyons and places like that. GPS is just all over the map. Now you can fix it. There's RTK. There's a bunch of things that you can do, but SLAM and technologies like that use vision with depth sensing, with AI, with anchoring, all this kind of stuff, allows you to get to extremely precise localization, and that's key. If you want to map the world, you have to do it properly from a localization perspective. So that's one element. The other element is for reconstruction. So I mentioned to you, we help insurance companies and our customers in case of a collision. We do 360, almost like like a matrix bullet time. That scene. So we produce that for a collision, right? For if you have an extra camera and you like that for your insurance, we will produce for you a 360 analysis of the collision, what you've done, what the other vehicles have done, what was their velocity, basically everything other than who's to blame. And that requires depth, right? Like if I want to measure the velocity, track the velocity of a pedestrian or a vehicle coming from the side, stuff like that, depth is also very important. HD mapping, super, super important for that. So depth sensing is definitely a key element we had to develop IP on in order to build breakthroughs in those fields.
When we look at the insurance markets, you have a real partnership with Coverwell Insurance that's focused on heavy-duty Class 8 trucks. Are you seeing an acceptance from underwriters and carriers across the globe, say in the Japanese market, the United States market, the Israeli market, or is it only certain markets where the insurance companies are saying, okay, Aran, let's figure something out, or is it just generally accepted across the board that your technology is good for their underwriting practices?
I think video telematics and our technology and insurance is a good place for Gibson saying the future is already here, it's just not evenly distributed, because you have different insurance companies with different levels of acceptance and eagerness to accept technologies, and many times it has nothing to do with the technology itself. It has everything to do with regulation, local state by state regulation, and it has a lot to do with how big you are, right? So I'll give you a couple of examples. Definitely, the higher the premium is, the easier it is to adopt technologies, right? Because if you have a $20,000 premium like an 18-wheeler has, right? There's no problem taking $500 and spending it on video telematics. If you save one collision of a truck, you basically paid for like 1,000 different cameras or more. So that's easier from that perspective. So more commercial, higher premiums, easier to adopt. Second is the question of regulation, right? Because in the consumer space, in the US especially, the pricing of insurance is heavily regulated, especially on the consumer side. So, for example, in California, you know how they calculate premium in California? There's a ballot measure from 1986 that defined the formula of what you can give discounts on car insurance. I kid you not. Okay, so in 1986 there were no dash cams.
Yeah.
So there are very few things that you can actually compensate on or incentivize driver on, and you can't really play with it. On the other hand, there are other states like Texas where you have more freedom, right? So insurance companies there are more free to adopt technology. It's worth it because they can incentivize the driver. They can give them discounts. They will adopt it more, etc., etc. So I can go on and on that, but I'd say in general, it's becoming indispensable, right? Like the way it works is your competitors adopt it successfully. They see reduction in loss. They attract the better drivers because when a better driver adopt a camera and you give it a discount, then your overall loss or portfolio became just a bit better. And then everyone else are stuck with the worst drivers. So you get this kind of interesting effect, but it's going to run through the system, right? Like there are other countries that are way ahead of the US. The US is a lagging market. Like if you go to Korea, 100% of the vehicles have cameras, have dash cams. In Japan, it's massive. In Taiwan, it's massive. In Russia, we know it's massive, but that's for another reason, for corruption. So that's how it goes. And I think the next 5 years, you'll see all major insurance companies adopting it and building programs for it.
Do you feel some point in the future, not giving a timeline, but some point in the future, either an underwriter or an insurance carrier demands that if you want to go through this carrier, you have to have a dash cam or we're not going to take you? Because insurance companies are very selective, especially as you go in the higher end markets, the Chubbs and the Pures, and you go higher up in the insurance pecking order, they get a lot pickier on who they're going to insure, not undersure. So do we get to a point where they say no dash cam, no insurance?
It's already happening. So you mentioned CoverWell. That's basically cover and staff. If you want to, if you want to do business with us, you have to install a camera. There are other insurance companies as well. We know we have a partnership with one in Texas that we'll announce, and there are some international ones. We have one in Israel, for example, that have a program But if you want the benefits of that program, you have to install an extra camera. So this is becoming more and more thing. It's still obviously niche, but I think this is gonna, capture more interest.
At the end of the day, what you're describing with the insurance comes down to economics. I'm really curious. What are the unit economics of Nexar's maps?
Typically, to map the road takes $50 to $100 per mile. Like if you want to build a Google Maps competitor from scratch or not from scratch, or that's what it will cost you. Right? It will pay for the those mapping cars and all the sensors and data upload and the drivers and the entire operation. The way we engineered it, we're talking about 2 to 3 orders of magnitude cheaper. Okay, so you can do the math of what that means. It allows us as a startup, as a company that it's 100 and some people. We're venture backed. We don't have the billions that Google and Apple has. It allows us to build something that is dramatically better than what they have. Right? It's all about the unit economics. Now, as I mentioned in the beginning, the unit economics is the barrier. New markets are created when you dramatically change the unit economics, right? Like when things that were not profitable before can now become profitable. Like I mentioned the parking one, right? Like you wouldn't mind if you live in a city, you wouldn't mind to pay $10 a month in order to get a heads up on where is the nearby available parking spot, right? We can handle $10 a month for this level of SLA, right? Because of our low unit economics. Google cannot, and that's a key point because all of these use cases, are opening up just because we managed to create this crowdsourced network.
It seems to me you have multiple revenue stream opportunities. So here I am living in the city, and I'll pay you $10 a month. You multiply that across hundreds of thousands of individuals living in a major city, and you're licensing the data to train autonomous vehicles. Is that the overall economic strategy, to have multiple streams of revenue for the company?
Yeah, so we had to initially focus because we're a startup. So we focused on some essential use cases like monitoring construction, monitoring potholes, monitoring this and that, right? But as we mature, we can unlock more and more use cases that allowed us to really, bring in more and more layers of revenues. But I think that this will converge soon to an sort of like a geo oracle, because at the same time as we're building the real-time mapping revolution, there's a much broader revolution that happened in the world of AI in the last year around large language models and ChatGPT and things like that. Now, today, that revolution is focused on digital content, right? It's focused on text and imagery and code. But what if you can connect it to the real world, right? What if you can create ChatGPT for the real world? And then the use cases are not determined by us anymore. They are determined by you, the user, right? That's unlocking a whole new future. But on that, I think we'll have more to say later in the year.
The real-time mapping revolution, as you stated, is going to be really interesting. Putting that together, in your opinion, what is the future of real-time mapping?
I think the future of real-time mapping at the end of the day is, first of all, clairvoyancy. First of all, knowing what lies ahead, like I mentioned, hundreds of yards ahead, tens of seconds ahead. That's the ultimate goal because it will be the biggest safety revolution that will go through, more than AV, more than ADAS, more than anything. So that's one thing. The other thing is digitizing the physical space and applying software to it, right? Like you know how they say software is eating the world. I say software is eating the roads, right? Like we want to deploy, and I'm not talking just about Nexar, talking about any company, any service that has to do with the physical world. If you want to deploy software, you need data, right? And you need the data to be precise and timely. I think the real-time mapping revolution will allow us to deploy software in more and more use cases to manage the physical world, manage the urban scene. I think that is going to be exciting. When your smart city will really be smart, that will be, I think, an exciting result.
Indeed, it will be exciting. And Aron, this has been a really exciting, interesting, and conversation. I thank you so much for taking the time for us today to explain real-time mapping and where you're going with Nexar. And as we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Well, I would love for them to first consider a camera, because probably most of them do not have a camera, and I think they would benefit, like I benefited last week. And then the other thing, I would invite them to come up with use cases, because when I talk about things like ChatGPT for the real world and stuff, a lot of it is what can you imagine? And I would invite people to try out a real-time mapping platform at mapping.getnexar.com. Think about their use cases and reach out, because we have all of these APIs available for developers and whatnot. So these are my 2 cents, I guess.
I like that. I'll summarize it this way. Build, build, build. There's an opportunity to build something meaningful. There's an opportunity to save lives. There's an opportunity to build convenience. So go out there and build. Check out the Nexar API. Today is tomorrow. Tomorrow is today. The future is Nexar. Aron, thank you so much for coming on SAE Tomorrow Today.
Oh, thank you. It was a pleasure.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.